بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. اليوم سنتطرق إلى درس جديد في علم الاستاتيكا، وهو على الاحتكاك أو خواص الاحتكاك. Welcome my dear student and our math program for secondary 3. Today we are taking new lesson. Its title Properties of Friction. My dear student, before we are taking properties of friction, look at the coefficient of static friction. My dear student, mu s is called coefficient of static friction. Mu s is a ratio between two forces, Fs and R. What is the Fs? Limiting or static friction force. Static friction force. What is our normal reaction? My dear student, mu s is called coefficient of static friction force. Is a ratio between Fs and R. Ratio between limiting static force or Fs and the normal reaction is R. Then we deduce that Fs is product of or multiply mu s times R. If we find mu s times R, this is static friction force. If we want to find mu s, we divided Fs by normal reaction R. My dear student, mu s is ratio between Fs and R, but Fs is multiply mu s times R. Look at, my dear student, now we are translate to kinetic friction force. What is the difference between static friction force and kinetic friction force? Kinetic friction force, my dear student, its symbol Fk equals mu k times R. Mu k coefficient of kinetic friction force, R normal reaction, Fk kinetic friction force. If a body moves on a rough surface, it's subject to the kinetic friction. The body move, then is kinetic friction force. Its symbol Fk. Look at the remark, my dear student. The first one is Fs mu s times R, denoted by only limiting static friction. The body is about to move, the static friction is maximum, equals, look at, F must be more than or equal 0 and smaller than or equal mu sr. Number 3, Fs or static friction force must more than kinetic friction force Fk. Therefore, we deduce that mu s more than mu k. Mu s more than mu k. Why? Because Fs more than Fk. Fs static friction force, Fk kinetic friction force. We deduce that mu s more than mu k. My dear student, resultant reaction, its symbol R dash. Resultant reaction is its symbol R dash. What is the relation between R dash and normal reaction? Look at, my dear student, if a body put in a table, then we have two forces. Number one, R, normal reaction. If the force acts on the body, then R dash is called resultant reaction equals square root R plus F. Look at in this case of limiting friction, R dash square root R square plus Fs square. My dear student, resultant reaction, simple R dash equals square root R square plus F square, Fs square. What is the Fs? Static friction force. What is the R? Is normal reaction. Since, my dear student, Fs equal mu s times R, then by substituting in a relation, then we deduce that R dash equals mu s square R square plus R square, or R square plus mu s square R square. Take, my dear student, R square highest common factor, then R dash equals square root R square multiply bracket contains 1 plus mu s square. Then R dash all resultant reaction equals what? R square root 1 plus mu s square. This relation between R dash and R dash is called resultant reaction. R is normal, but mu s is called coefficient static friction force. Then remember, this rule is very important. R dash or resultant reaction equal R multiply square root 1 plus mu s square. My dear student, now we are translate to angle of friction. Lambda is measure angle included between R dash or resultant reaction and normal reaction. Look at when a body put in the table and R is normal reaction, its weight W, the force B act on B, act on it, then F is limiting static friction force. We deduce that R dash is called resultant reaction. It's resulted between R and Fs. Lambda is angle between what? Excellent student. Resultant reaction and normal reaction. My dear student, look at lambda equal or angle between what? R dash and R. My dear student, when Fs equal mu s R, then tan lambda equals Fs over R. What do you mean Fs over R? It's called mu s. Excellent student. Coefficient of static friction force mu s equal Fs over R. Then what you deduce? Excellent student. Tan lambda equal what? Mu s. What you mean? The angle or the tan angle between R dash and R equals what? Coefficient of static friction force. Then we deduce that tan lambda equal mu s. My dear student, by substitution about R dash equals R multiply square root 1 plus mu s square equals R multiply square root 1 plus 10 square lambda. Why? Because mu s square equals 10 square lambda. Then r dash equal r square root what? Excellent student, 6 square lambda. Why? Because we were studied in the previous year 1 plus 10 square lambda equals 6 square lambda. Then we deduce that r dash equal r sec lambda. This is the relation between r dash and r and the angle between them. What is the relation between r dash, r and the angle between them? Resultant reaction r dash equal product or times of r normal reaction multiply sec angle between them. Then we can deduce sec lambda equal r dash over r. Why? Because r dash equals r sec lambda. By using cross multiplication, we deduce that sec lambda equals r dash over r. My dear student, we know that r dash equals r multiply square root 1 plus 10 lambda. 10 square lambda equals what? Mu square s. What is the mu square s, my dear student? This coefficient of friction force. We know that lambda is angle between r dash and r. What is the r dash? Resultant reaction force. What is r? Normal reaction force. Then when we find r dash by using r and angle between them, we use this rule. What is the rule? R dash equal r sec lambda, or sec lambda equal ratio between r dash and r. My dear student, now we are translate to important title properties of friction. My dear student, look at the first property. Look at, my dear student, properties of friction. The first property is the force of friction is hidden force, act to resist motion of the body. Any force of friction is hidden force, act to resist motion of the body. Number 2, the force of friction always acts in the direction opposite the two parallel direction of movement. Friction force opposite to movement of the body. Number 3, magnitude of friction force equals magnitude of tangential force and increases as well as tangential force increases as long as the body is in equilibrium till to reaches its maximum value. What is the maximum of friction? Fs of this moment of the body is about to move. My dear student, look at the first example. The first example, body of weight 15 kilogram weight is placed on a horizontal plane. Horizontal force of magnitude 5 kilogram weight act on the body. Remember, my dear student, we have body, its weight 15 kilogram, placed on a rough horizontal plane. Horizontal force of magnitude 5 kilogram weight act on the body. Then the body became about to move. What is the required? Fast Find the coefficient of static friction between the body and the plane. Second, if weight of magnitude 3 kilogram weight is put on the body, find the magnitude of horizontal force which act on the body and what is carries of weight to about to move. My dear student, look at the solution. The first, the body is about to move. Look at the body. My dear student, look at the body. Act on the table by two forces. Its weight 15 and reaction or normal reaction R. Look at the force 5 act on it. This body on rough plane. What do you mean? Yes, mu SR. Rough plane. Static friction force. Fs equal m mu SR. We have, my dear student, mu SR equals 5. Two equations of equilibrium, mu SR equal 5. This is equation number 1. Number 2, R equals what? 15. This is equation number 2. By substitution, from 2 to 1, we deduce from 1 to 2, mu S equals what? Mu S times 15 equals 5. Then mu S equals third. 5 over 15 equal 1/3. Then coefficient of static friction force equals third. Coefficient of static friction between the body and the plane equals third. This is the first. Now translate the second required. Look at the opposite figure, the body, and put another body. Its weight 18 kilogram weight. Reaction or normal reaction is R. What is the force B? Look at, we form two equations of two equilibrium equation. R equal 18. This equation number 1. Number 2, B equal mu SR. Mu S equals third times R. R equals what? 18. Then B equal third times 18 equal what? 6 kilogram weight. The second required, B equals 6 kilogram weight. Now we are translate to another example. Look at the important example. A body of weight 15 kilogram is placed on rough horizontal plane. If measure of angle of friction between the body and the plane is 30 degrees. Find, number 1, the horizontal force which is enough to make the body about to move. Number 2, the force inclined to the plane at angle of measure 30 degrees and makes the body about to move on the plane also. Look at the solution. My dear student, look at the body on rough plane, has weight 15 kilogram weight and normal reaction R. The force B act on the body, rough plane, then we have Fs. My dear student, Fs equal mu SR. Mu SR equal Fs means mu S equal 1 over square root 3. Then we deduce that mu S equals 10 lambda. this relation between mu s and tan lambda. Remember, lambda angle between x and student, r and r dash. Then mu s equal tan 30, 1 over root 3. Therefore, the body is about to move. The two equations of equilibrium, number 1, b equal 1 over root 3r. Number 2, r equals 15. By substitution, from 2 to 1, b equal 1 over root 3 times 15. Answer is 5 root 3 kilogram weight. Then b equal 5 root 3 kilogram weight. Look at, my dear student, if we put another weight, then if b inclined the horizontal by angle 30, we resolve or resolution be about x-axis and y-axis. Two components in x-axis and y-axis, b in x-axis b cosine 30, but in y-axis b sine 30. Then we change two equilibrium equation. The two equations of equilibrium are number 1, b cosine 30 degrees equal 1 over root 3r. R equals what? 3 over 2 b y cosine 30 equals what? Excellent student. Cosine 30 equals sine 60 root 3 over 2. By substitution about cosine 30 root 3 over 2, then we deduce that r equals 3 over 2 be this equation number 1. R plus b sine 30 equals 15, this equation number what? Number 2. Then r plus sine 30 equal half. R plus half sine half b equals 15. This equation number 2. We have two equations. R number 1, r equals 3 over 2b. Number 2, r plus 1 over 2b equal 15. We have two equations in two unknown variable, r and b. R normal reaction, b is a force. By using substitution method or omitting method from third prep, find the value of r. From 1 and 2, find the b 7.5 kilogram and find the another example. My dear student, look at the important example. Body of weight 26 Newton. It's placed on a horizontal plane. Two forces of magnitude 7 and 8 newtons. Inclined between them an angle of measured 60 degrees act on the body. The two forces are horizontal and lying in the same horizontal plane with the body. If the body became about to move, what is the required? Number 1, find the measure of angle of friction. Number 2, find the resultant reaction. Look at, my dear student, the solution. Look at, my dear student, body on rough plane. Has weight 26 and normal reaction R. We have two forces act on the body. Look at the two forces act on the body, and 7 and 8 two forces act on the body, angle between them 60. What is the resultant of the two forces? If we have two forces 7 and 8. Between them, angle between them equal 60. This resultant equal 13. Why? Because if we have two forces, 7 and 8 active between them, angle between them 60, then the resultant is 7 power 2 square root 7 power 2 plus 8 power 2 plus 2 times 7 times 8 cosine 60 equal 13. Then, my dear student, body about to move under action of the two forces, resultant of the two forces equal Fs mu SR equals 49 plus 64 plus 2 times 7 times 8 times cosine 60 or 1 over 2. Answer is 13. Then resultant of two forces equal 13 Newton. The body is at a limiting equilibrium. Mu SR equals 13. This number 1. R is 26. By substitution from 2 to 1, then mu S equals 1 over 2. What do you mean? Coefficient friction force equal 1 over 2, then tan lambda equal half. What is the angle? Lambda equal shift tan or tan negative 1 of half by using calculator 26 degrees 34 minutes. The resultant reaction R dash equal R multiply square root 1 plus mu S square. Then R dash equal 26 multiply square root 1 plus quarter. Mu S equal half. Square root 1 plus mu S square equals, then R dash equal 13 root 5 Newton. This resultant reaction force. My dear student, by the end of the lesson, we know that static friction force, kinetic friction force, and we know that Fs more than or must more than Fk. What is Fs? Static friction force. What is the Fk? Kinetic friction force. Then, if we have Fs more than Fk, we deduce that mu S more than mu K. What is mu S? Coefficient of static friction force. What is mu K? Coefficient of kinetic friction force. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you.